Hi fellas, welcome to the last video of week one. This one's actually mostly examples here. But let's get started. I know you guys are probably anxious to finish up the last video, so here we go. If we have a parabola that's in this form, a quadratic function in this form, we can find the vertex of the parabola. It's negative b over 2a, and the function value at that negative b over 2a. And remember that if a is greater than 0, then the vertex is a minimum value, and if a is less than 0, we're going to open downward, and we're going to have vertex is going to be a max. Okay, so we're going to primarily use this information now. Let's do a couple examples. First, let's find the zeros in the vertex of the function negative 2x squared minus 3x plus 5. We want to graph and then do all the things that we would normally do. Well, the first thing that we want to do to find the zeros, we want to use the quadratic formula. Okay, and hopefully you guys remember your quadratic formula. I'm assuming that you do. And so x is equal to negative b plus minus square root b squared minus 4ac over 2a. This is going to get me get the two zeros of the function, or at least tell me the types of zeros that we have. Remember, we can have a couple different options, which all depend upon this term right there, which is my discriminant. If this term right there is greater than 0, then we have two real solutions. Whoops. Okay. If it's equal to 0, we have a double root. Not writing very well today. And down here, if this is less than 0, then we have imaginary roots. So hopefully you guys remember that. If not, you should review it, because I'm assuming that you understand and know the quadratic formula. Okay, so with that said, let's go on. So if I plug in, let me erase this stuff here. If I plug in there, you see I get 3 plus or minus square root of 49 all over 4. Okay, and then obviously I can simplify that, and let's do that, and I get that there, and the final answer would be negative 5 halves, comma 0, and 1 comma 0. These are my x-intercepts, and these are my zeros of the function. All right, so that was finding the zeros, and then we want to find the vertex. Well, the vertex here we know is negative b over 2a, so here a equals negative 2 and b is equal to negative 3. So negative b over 2a is simply going to give me negative 3 over 4. Okay? To find the y-coordinate, I simply plug this negative 3 over 4 back into the function. And if I do that, I get 49 over 8. All right? And the last thing I want to do is to graph it. My axis of symmetry, again, should be the vertical line. X is equal to negative 3/4. Right? It's the x-coordinate of the vertex. And if I do that, you can see my axis of symmetry is, in fact, x equals negative 3/4. And there's my vertex. Okay? Let's go on to the next one, which is a word problem. Again, I would advise you guys to read through these and try to solve them. But basically, a rancher has 200 feet of fencing to which enclose 2 adjacent rectangular corrals. What dimensions should be used that would maximize the area? All right, so again, I have right here, there is fencing here all the way around, and we want to maximize the area. So the area function here is simply this, base times height, 2x times y. But we also have a stipulation that I can only use 200 feet. So my perimeter, which is 4x, 1x, 2x, up here is an x, up here is an x, and I have a y here and a y here. So perimeter is 4x plus 3y, and I can only use 200 feet. Now the key is to get this as an equation of one variable. And so what I can do is solve this one for one of the other variables and plug back in. If I do that, if I solve this for y, I'm going to get 200 minus 4x over 3. And what I want to do is take this and plug it in up here for y. Once I do that, I now have a function that is solely dependent upon x. And what I can do there is simplify a little bit. And I'm going to note that this is a parabola. Okay? And note that a here is negative 8/3, b is 400 over 3, and c is equal to 0. But what I want to do is to take a graph of that function. If I do that, that's what I have. And I'm trying to maximize this function. Well, guess what? The maximum is going to be right up there. Okay? And a couple different options. Obviously, we could do the negative b over 2a, which would be a little bit messy. Okay? But we can also use our calculator here. All right? We use the maximum feature on the calculator, and we already know how to do that. We learned that in the last in a video already this week. If I do that, I get x is equal to 25 feet. Once I find that x is equal to 25 feet, I need to go back and find out what y is based upon my perimeter equation. Remember, perimeter was 4x plus 3y, and that was equal to 200. And once I know x, I can go back and solve for the y. And if I do that, I get y is 33.33 feet. Okay? Let's do one more example. Another word problem. The height of a punted ball is given by y equals 35t minus 4.9t squared. Determine the max height of the ball and the hang time. And so what I'm going to do here is there's my graph. Okay? Where t is going to be on this axis and y is going to be on that axis. And here's my axis of symmetry right there. And so this one's a little bit more straightforward. I just want to maximize this function. And so again, I can just use my negative b over 2a, or I can simply use it in my calculator. I can find it. That's going to give me the t coordinate to the maximum height. To find the maximum height, I plug this into this equation, like that. And I get 62.5. And remember that the time, the total hang time is just going to be, because of the symmetry here, if it takes 3.57 to get to the top, it's going to take another 3.57 to get to the bottom. And my max hang time is going to be 7.14 seconds. Okay, so there's a couple different examples there. I could certainly have used my calculator to find that point, or I can simply use the negative b over 2a. All right. Here's some problems. A couple word problems right there. Make sure you guys get those. Any questions, again, email me. Last video of the week. Hope you guys enjoyed it. Problem set is due Monday at noon. Make sure that you guys send that to me by noontime on Monday. All right, fellas, have a good weekend or rest of the week, and email me with any questions. Have a good day.